I go with the last section, which is about, as Home was saying, life cycle design guidelines and example for clothes. So what it means is that we saw the strategies. Now we go even further and we see how in practice these strategies could be, could be made, could be practiced, and how brands are doing that, and deep dive in the practice, let's say. So product clothing. We see again the strategies. Just an overview, not repeating those, but again remember the connection that they could have between one another. And we start with example about minimizing material consumption. Again, just a reminder about the life cycle. Yeah, I'm not, sorry, again, the bar is, okay. I'm not going, obviously not going through this text, but what you see here is an example of guidelines. So on the top, you have the strategy that we have discussed and we understood why it reduced environmental impact. So it's minimizing the material consumption. And below in orange, we have the guidelines. So how this could be done. The first one and the easiest is minimizing the material content, but another could be minimizing the clothing scraps and discards, for example, during production. Another way could be minimize or avoid the cloth packaging. So you see that we are going closer and closer to practical solutions, practical ways to reduce environmental impact. Another one is minimize the material consumption during the use. So for example, maybe combining, having double fast clothing design. So you, what you have, during the use phase, you just have one cloth instead of having two. That's just an example. So we're not going now reading the guidelines. These will be there for you. We just see some examples, if my mouse works. Okay, first one is this one. It's called Son of a Tailor. And what the company is doing is basically using a particular technology, 3D knitting technology, through which they can make, for example, a pullover without any cut off. So reducing the scraps from, for example, 20% to 1%. What they are doing also is having custom fitted T-shirts and some kind of some products all oriented toward the maximum customization and personalization based on your body and or efficient technologies. So, which is the specific design choice that allow to minimize the material consumption here? In this case, the guideline that is applied is minimize scraps and discards, and in particular, the guideline that has been applied is selecting processes that reduce the scraps based on 3D printing, CNC, whatever. The guideline is general, so it's not related. It's not specifically made for this single case. So could be 3D printing, could be CNC, depends on the cases. But this is what is applied here. And not only that, but also designing some cutting paths to minimize the scraps. So you design the clothes and you foresee how the production will be made, so you reduce the scraps. And this is an example. So again, another example very similar. So I'm not repeating the whole question, but it's using a 3D body scan to produce custom fit jeans. Okay, so this is again making jeans precisely according to your body and precisely to your order, allow to first of all allow to save materials based on the production, because it's exactly the material needed for those jeans. And second, it also avoids unsold, for example, products, and so you are again reducing the material consumption of the product, avoiding scraps and discards. Here is another example that maybe no one of you have ever, I don't know, but I guess that no one of you has ever associated with sustainability, neither me until a week ago. So I was thinking, let's think about the keyway. What's happening with the keyway? I guess many of you know the product. but you have a reversible pocket that is becoming the packaging. This is both a functional solution, so you have your keyway when you go around on a trip or whatever, but also this is the way you usually receive the keyway at the retail. I mean, you buy the keyway in the pocket. And so again, what is a specific choice applied here to minimize material consumption is obviously to minimize or avoid the cloth packaging. And in particular, the guideline that has been applied, I don't know, I guess not intentionally, but what's been applied is designing the packaging to be a part or become a part of the garment itself, such as reversible pockets. So that's an interesting example. So those were the 3 examples for minimizing the content of material. About the minimizing of energy consumption, again, we already spoke about that. We know what it means, especially important for the clothing care part during the use phase. And again, we have some guidelines in orange. Some guidelines in orange and some sub-guidelines in white. We're not reading that, but the general guidelines obviously minimizing the energy during the clothing use. This could be done in very, very different ways. You can design clothes to be washed at low temperatures. You can, I don't know, separate the washing of different parts. Then it goes to obviously the creativity of the designer to take the guidelines and to turn them into obviously viable solutions, because guidelines are not solutions, are just suggestions, way to put in practice a strategy. But here we have an example. So this Filium textile is a technology that they use a technology that activates those hydrophobic properties in natural fabrics. And so yeah, you have this effect of liquid repelling the liquid. So you avoid stains, the clothing can resist to odor, etc. And why is this reducing the energy consumption? Obviously, it is reducing during the clothing use, and it is about reducing the need of washing, because if you don't, if you don't make your t-shirt how to say, dirty or smelling bad, you don't have to wash it so frequently. And so that's the guideline applied. Similar, but not the same, is what Patagonia is doing together with HeyQ. HeyQ is a silver ion-based additive. So the concept here is a partnership. So it's quite interesting, but they add to Patagonia clothes, to some Patagonia clothes, this treatment, which allow to keep anti-odor, basically. And so they smell fresh for longer. And again, this is the same guideline apply. So you don't have to wash your Patagonia jacket or Patagonia clothes so frequently, because there is no need of doing that, because the clothes keep being perfectly fresh and it's good to go out. So that's an application of the guideline. Another strategy, minimizing the toxicity. Again, overall the life cycle, and it's about reducing at most the substances that are toxic, and we're talking about both materials and energy. And again, we have our strategy with our guidelines, with our sub-guidelines. So it's a matter of selecting in this case. So select non-toxic and harmless materials for the clothing system. So we refer now again to the whole clothing system, and select non-toxic and harmless energy resources. Yeah, and this could be done in many different ways. Could be applied for processes that are particularly using substances that are toxic, like dyeing. The dyeing process for clothes is maybe the one that is using the most of toxic substances. So you could, for example, avoid those processes at all, or maybe use some non-toxic substances to do that, or maybe for the finishing, you can just replace some processes, design the clothes in order to not having the need of those finishing processes, and etc. And the example here is very simple. It's FLAVIA ARANHA. It's a small brand from Brazil, and what they are doing during their dyeing process, they are just using non-toxic coloring resources, such as tree barks, fruits, leaves, and roots, and they avoid any heavy metal. So obviously, it depends on different situations, but this is a perfect example of what we were saying. So just selecting the right substances and avoid the dyeing processes when possible, or just select the one with the lowest toxicity. Another strategy, we go for the resource conservation and biocompatibility. So you remember we were talking about renewability, and how renewability concept is also has to be taken in relation to the context in which you are. And in this case, the guidelines are to select, again, it's a matter of selection, renewable and biocompatible materials and renewable and biocompatible energies. It's true that I'm saying it's a matter of selection, but you know that the selection is also could be also influenced by the design. So if you are a designer and you are obviously making the life cycle design of a product, of a clothing product, you are taking in consideration all the stages, and so maybe you can have a solution, you can design a solution on the product itself that is connected to, I don't know, a background process which is which can be based on renewable energy instead of fossil fuels. So it's not that design is not an impact on this. It's just maybe not so direct as some other guidelines you can imagine. Okay, the example here, I guess you all know about this. It's orange fiber, and they are, I mean, it's a fabric made from citrus juice byproducts. So it's a result of other production processes, and they have kind of a good network in which they can, I mean, they manage that resource carefully in relation to the, I mean, they collaborate obviously with the citrus agriculture sector in order to make this renewable. But the concept is using orange byproducts to create a fiber through a proprietary technology which is just under their control, and making some beautiful clothes. So again, it's a matter of selecting the renewable material, and what you are doing here, which is the guideline applied, is using materials from other production processes and consider the use of rapidly high renewable materials like plant-based fibers. So orange is considered in the right context could be a rapidly high renewable material. Let's move on, still on this strategy, and we have this collection by Wolford, and yeah, it looked like common clothes, but it's made. I mean, several part of the collections are made through biodegradable alternatives to elastane, for example, and they use a compostable polymeric fiber, so it's not like for after consumption phase, this is going to be back in the environment, let's say, without any damage. And many of the collections are designed to be recycled then, and based on recycled materials and rapidly renewable textiles, which is Aquafil Econil. This textile is the one that they use for some collection, and is a textile made from water nets, let's say ocean plastic, let's say. Not only, it's actually another case study will be interesting for that. They have a very structured network in which they collect plastics from the ocean, from different origins, from even maybe some land plastics, and they produce this fiber, which is an high quality fiber. And you find this case study also in the book. But the point here is that Wolford is taking advantage of this, is selecting these materials, which are both highly renewable and also biocompatible because they are biodegradable or compostable to make clothes. So the choice that is enabling the resource conservation is selecting the right materials, and so again consider the use of those renewable materials and biodegradable materials. Okay, so we move to the next strategy, which is designing for extending the use or the intensification of clothes. And here we have a lot of guidelines and sub-guidelines, because we are talking about, you know, clothing maintenance, clothing care, clothing upgrading, extension, adaptation, or even reliability is a part of this. Because if you make a cloth to be reliable and simple, then or even not too much complex and resistant to, you know, stress, this could last more, could be more reliable in this sense. But we have also facilitating their use. If you use again a cloth, obviously you are extending its lifespan. Or we have also the remanufacturing. Remanufacturing means that the clothes can be bring back to industrial processes and brought to as new conditions. And you have finally the guideline of intensifying the usage that we were mentioning before. They could be multifunctional clothes or clothes to be used by different people, different situations, etc. So you will have a look at that. First example that I'm bringing here is the layer shoes. It's actually it's a product, but it's not again on the big market, let's say, and it's a modular shoes in which you have different components. This is a winner of the James Dyson Award, so it's quite recognized as a good, it's a very good project. But basically, you have the module of the sole and the module of the upper part, which are connected through these these ropes, these laces, and it's very easy to replace the parts, to maintain your shoes. So you can just disassemble the rope, you can just replace the sole or the upper part, and it's done. So what is the choice applied here to facilitate, in this case, the clothing maintenance? It is to facilitate the replacement of easy to wear out parts of the clothes. So obviously the sole, it wears out very easily. So maybe it's the one that you are going to change more. And this design is facilitating the operation. Other example is Lemuria, and you see from the picture different dresses. And these are made. Actually, they are the same piece of cloth. So the same garment is designed to be adapted and to be worn in different ways. So it could be a long dress, could be pants and skirts, could be, you know, there are tons of customization options. And yeah, what is happening here is that cloth is multifunctional and allowed to be transformed in different ways. So the choice is to facilitate the upgrading, the extension, and the adaptation to different situations. So this is the guideline applied. The sub-guideline is a modular design that is reconfigurable and that can adapt to different spaces or even climatic conditions, etc. So again, this is a good example of how this guideline has been implemented. And now we move to the next strategy, which is the extending the lifespan of clothing material. And here we are talking about facilitating the recycling, as well as the energy recovery and the composting. Said that energy recovery needs to be carefully considered and to be assessed in its environmental impact, because obviously it means to burn stuff and recover energy. But I mean, again, using a life cycle perspective, you need to be careful on that. About extending lifespan of material, we have several guidelines here again. So it could be a cascade approach. Cascade approach, it means to recycle something into a new product which has lower requirements. Could be lower aesthetical requirements, could be lower functional requirements. An example could be like you recycle, I don't know, a sweater into the padding of a jacket. So you don't see anymore the material. So it's not important that its appearance, its aesthetics is kept, but it could be used as a stuffing for other things. Other guidelines is to select materials with obviously with most efficient recycling technologies. So this is again a matter of choice, and you can facilitate the collection and transportation of the disposed clothes. And this it seems far from design, but it could be a matter of just designing something considering the context in which it's going to be distributed, and so having a good identification of a good I don't know, a good design to be stored and passed among the different actors of the recycling value chain, and so this is part of design. Final one is the identification of clothing materials. Obviously, if you have to, you can facilitate the recycling if you well identify where things goes. So this is 100% cotton, this is 100% polyester, so these have different destinations in terms of recycling. Last two guidelines are minimizing the non-compatible clothing materials. So obviously, if you are designing and you are designing to facilitate the recycling, it's important, or could be important, that you don't design, you put things together that are not going to be easy to recycle together. So you don't make a leaf of cotton and one of polyester, for example. And obviously facilitate the cleaning. That's the other and last guideline for this strategy. We have an example here, which is Rapanui, and it's difficult to find example in this sense. So because as we said, recycling, even though in the last maybe months, in the last year, is raising up also the mechanical recycling of some clothes, is not easy to recycle them. So in this case, what Rapanui is doing is adopting, first of all, a monomaterial strategy. So it's 100% cotton, and so this make also that it's very the purity of the material makes an impact. So the quality of the cotton is it could make a difference in terms of recycling. And yeah, and the second part is that it's designed to be sent back. So they make the product. The user can send it back, but since it's sent back to the producer, they know how to treat that and they know how to recycle that. So that's the difference. So what is happening here is recycling, selecting the good materials with in terms of technologies and minimizing the number of non-compatible ones. Second one, also interesting, this case, you can see the concept from the image. It's where to go. It's a jacket that actually what they offer is a technology, which is a seam separation technology, in which they can easily separate the parts, and so the destination for recycling is easier to make. No, so in this case, all the components can be distinguished and can be removed and can be addressed to different paths for disposal. So the choice applied here is to minimize, first of all, the number of non-compatible clothing materials and facilitate separation. In this case, we are talking about facilitate the separation of non-compatible materials. So it's a seam that can be easily removed. So I can, even if I have non-compatible materials, it's not a problem because I can easily detach one from another. Okay, the last one is the facilitating the clothes disassembly. So again, we already talked about that. It could be facilitating the use extension or the material lifespan extension. And in terms of guidelines, these are the specific ones. So the first one is you can reduce and facilitate the operation of clothing disassembly. So it's very general, but it could be in terms of prioritization. So you have easy access to things that are easy to damage. So it's very easy, for example, to disassemble buttons or to disassemble leaves, or I don't know. But the point is this one. So making, for example, the easy access, or maybe build the product with sub assemblies. So I don't know, for example, jackets. I see now I'm reading the 4th guideline. You have sometimes the waterproof cover, then there is an internal warm layer, and you can just separate the two, or you have a zipper. I mean, there could be tons of design solutions to facilitate this separation, and so facilitate could be, I don't know, upgrading, maintenance, whatever, or recycling. The second one is to design and or co-design. This means that could be also in obviously partnership with technology providers or different actors and stakeholders from the value chain for clothing crushing separation. So it could be that crushing some parts of the cloth is a good way to save at least what is recyclable. Okay, so the example here is again from Patagonia. It's not a mainstream product, but it's quite interesting because what you see there is a shoes that is made of two modules. One is the sole and one is the upper part. That can be very easily separated and maintained and whatever. And so what is applied here is reducing and facilitating the operation of this assembly, and in particular, preferring some modular structure. So I have a module, I have the second module, they just assemble together, I can interchange them, and that's it. You can easily understand how strategies are also, strategies and guidelines can be also horizontal. What I mean, it means that, for example, these Patagonia shoes, it's also a great example for extending the lifespan of material, or is a great example of, I don't know, what could be also reducing the, I don't know, the energy consumption, because you have just to now I'm improvising, but you can just wash the upper part, so you don't have to use more energy to wash all over the shoes, or yeah. So it's also good for recycling. Again, we are talking about the assembly, so it's facilitating other things, but these apply to many other projects. So maybe you're applying some design solutions, some life cycle design solutions that are facilitating one of the strategies, but also this could be easy, so it could be useful for other ones. So it's not said that one example is just putting in practice just one guideline or one sub-guideline. And the other and last example I would say is again a shoe, which is made in this case to be separated through this. It's kind of a, I mean, you have the lower part 3D printed and the upper part made of wool, and so the upper part and the lower part can be separated easily. So what is happening here is constructing the product to make it easy separable and manipulatable in their sub-assemblies. So the lower part is completely autonomously 3D printed, and then is attached to the upper part, similar to the other shoes that we saw, in a way that then it's easy to distinguish, but they could be considered as sub-assemblies. Okay, so this was the last case study. I hope that this gives you more practical overview on what life cycle design could mean, and maybe also some thoughts and ideas that could be important for your exercise or whatever. Obviously, there are tons of case studies, and you can go through all the guidelines or all the things that we saw now, and even more on the platform. So the platform that Carlo already mentioned, that is collecting a lot of resources, you can just go on case studies on the left, and then if you want to navigate case studies just as a, as a wall, you can do it, but you can also go through the criteria, and you will find all the strategies and guidelines that I explained to you, and you can see all the case studies associated with each strategy and guideline.